Hello students, good afternoon. Today's presentation we are going to see about the drilling cost analysis. So how we are doing the drilling cost analysis in different types of drilling, horizontal, whether it is horizontal drilling or it's a vertical drilling. So in the past videos you will learn a lot of things on different kinds of petrol software, etc. But today's presentation we are going to see about the uh, drilling cost analysis. So let's go to the presentation. So drilling cost analysis. So what we are going to learn in the drilling cost analysis after the learning this points. So you know this after this lecture you will be able to understand the what are the benefits, what are the limitations, what are the problems you are facing. So there are some lot of data are inaccurate, not accurate. So how you are doing the calculations based on different analysis. For example, cost per foot curve and economic evaluations by using the graphical analysis and also the different type of drill bit, which type of drill bit is which is cost effective like that, and also the selection of drilling variables and which will be more effective, and also that finally we will be learning the description, how we are analyzing the drilling process. So now, so what is the basics here? So the basis that you are going to learn, there is nothing will be accurate drilling. Drilling has been done. So based on your different field data, past bit records and different plannings and the valid tools, etc. So we have to complete the standard forms which are available, documented, and which are available on the rig site. And also dull bit evaluation, dull bit grading also we have learned already in our past videos. So the dull bit evaluation also gives the very good information on grading. So that also can be done, uh, such as WOB, weight on beat, rotary speed or rotating time, etc. But in the modern analysis or in the recent analysis, so there are a lot of points, a lot of developments has been made in the rock drilling. And we are going to see here different type of bits, for example, available bits, roller, cone bits, fixer cutter bits, etc. So now first one is cost per foot analysis. So what is the cost foot per analysis? So there is a basic formula which is available for the analysis, calculation of cost per foot analysis. So the basic formula is cost per foot equal to hourly rig cost, that is your trip time plus drilling time, and bit cost divided by the footage total drilled. So this is the basic formula which will be used for the selected or given application. This is the real cost per foot analysis by this equation. So for example, the rig cost $400 per hour, trip time is 1 hour, so bit cost 15. Cost footprint is calculated by this analysis, by this formula. So you are getting the drill bit cost 42.9 per foot and 38.36 per foot. So now we can see the cost curve analysis. You can see that the cost analysis is represented graphically. So when the drilling begins, the cost per foot will start decrease rapidly. Therefore, the longer the bit is on the hole, the more straight line the curve becomes. Therefore, when the curve begins to increase, it becomes necessary to pull the bit. So this is the one type of analysis you can see in the graph. Cost per foot formula. So the bit can be pulled when there is no longer economical. So your economic analysis is very poor, then we can remove the. Therefore, in that cases, we can do this type of curve analysis. Next one. So now this drill bit rate data record also shown here, and the cost per foot calculations including downhole motors. So when the downhole motors are used and charged at an hourly rate, so they can be included in the cost equation. So here this is the formula, C equal to CRG TD plus TF plus C bit plus C motor into TD divided by D, where C is the cost per foot for drilling the section of the hole, then C rig is the rig cost per hour, then C bit is the drill bit cost for each, then cost per hole of the drilling, C motor, then D is the distance of the total drilled, and TD is the hours spent on drilling, and TF is the hours spent during the tripping. That is your tripping time. So this is the formula which is utilized for cost per foot calculation, including the downhole motors. So now we can see here the bit style, everything, TDC, C, meter, D, and the total cost. So this is the well number, different wells are shown. Then target cost per foot and targeting the rate of penetration. So the ROP equal to D by TD. So this is another formula, targeting cost put and targeting the rate of penetration. So this is the another method. Then, so this is the example by the rig cost is given 2083 per hour, bit cost is given, then section length also given, drilling time. So we are calculating the cost per foot. So the offset well cost per foot equal to 346.73 per pound per feet, and target cost is 294.72. So there is the performance calls for 2 bit runs, that is using a Mac drill, and the section established is the length of the drilling is 3573 feet. Then target ROP. So next one you can see here, target rate of penetration is also shown here. Rig cost, bit cost, motor cost, then trip time, and you are targeting the cost of drilling interval. So equals now targeting the cost of drilling time equal to, so you are getting this formula and getting the result like this. Now next, so this is another example, target ROP equal to target drilling hours, which are getting 436.8 per hour, then total target ROP rate of penetration 8.6 per foot hour. So there is so this is the drill with 2 bit runs, and average of ROP is at least 8.6 feet hour. Therefore, the target cost per foot will be achieved, and the full list of price will be charged to the client. There is also second examples also shown with motor. So you're getting the targeting ROP is equal to again second 17.8 per foot per hour. So after consulting all your database records by this company. So you can see Intech or Baker Hughes. Rate of penetration is 18 feet per hour is attainable. Therefore, the client should do the following terms. So what are the terms? If target cost per foot estimated is 147 achieved, so there will be a specified motor will be charged at the standard hourly rate. And second point, if the cost per foot is more, exceed the your target amount or figure, then the hourly charge for the motor will be scaled down until the required target is achieved. Therefore, the minimum hourly rate will be motor will be 60% of the list price. Third point, if the trips are required, they are not related to the motor orbit performance, the trip times will not be included in the cost per foot calculation. Then number 4, drilling time will be calculated on the basis of bottom drilling hours. So that is excluding the connections. Number 5, cost per foot calculations will be mutually agreed between the oil company and the Baker Hughes or other companies before the job starts. And the normal rates of personnel and standby maintenance will be applied. Therefore, the cost per foot calculations to evaluate the runs. So this is the evaluation by this type of equations. So now we'll go for the graphical standard per foot formulas. Now let's go to the break-even analysis. What is meant by break-even analysis? So using the offset data. So they are given the chart can be used for the any price, offset data, then total footage. So you are getting the C equal to 53.45 per feet target cost. So you can see the plot, break-even performance, trip per hours, then plot to the 0, then you are getting the second point, then draw the straight line through the points A and B. So this is the break-even performance. You can see here. So trip hours and second is your footage calculation. The insert bit cost plus trip cost divided by the offset cost. So offset cost you are done already. So we are getting the graph like this. So by break-even performance, the diamond bit. So you are doing the description, roller count bit and diamond bit. So the items A, B, C, D, F, G, H, I, J, K, different dull gradings. So now plot the J value, then plot the K value, then draw a straight line extending the points J and K, then footage combination of this break-even point and any point above the extending through the J and K indicates a cheaper cost per foot. So any point below the line indicates higher cost per foot for the diamond bit. So this is the analysis of roller cone bit and diamond bit. So the optimization next is different type of formations, soft formation, medium formation, odd formations. So in the soft formations, you have to increase the rotary speed, which improve the penetrations rate, and lowering the weight on bit. Then medium formations, your increased RPM, you don't have any result, and moderate RPM with moderate WOB should maximize the drill bit rate and reduce the bit wear. And for odd formations, we have to increase WOB, weight on bit, more important than increasing the RPM. So moderately high weight on bit with minimum RPM will give the yields that most optimum drill rates will be giving. Then, so this is the WOB versus rotary speed of the cost analysis. You can see here drilling rates, WOB and rotary speed analysis. And Next is example of cost analysis. Drillers and logging personnel should be communicate before the start of the test, then starting pump, starting rotary speed, then start drill of test. So these are the drill of test parameters, maintaining the each wait on bit for 60 seconds, flow rates, 520 GPM, bit types, then test 1, test 2, test 3, test 4. We have done these things. So after the completion of the drill of test, they select the RPM and WOB, which provide the penetration rates. So a graph will be shown here. You can see here the graph. The lowest point of the graph indicates the optimum WOB and the variation of the drill tap test and of the mark of the Kelly in each segments. So you can see the test is repeated for several different values of rotary speed in order to find the optimum rotary speed. So this is the surface indicators. Next one. After the drill rate optimization, we'll go for the surface indicators. So here there is a constant torque, irregular torque, increases in torque or decreasing the torque. So these are the points. We can go through it. That is irregular torque, key seating, excessive WOB, etc. Then increases in torque. That is your increased filter cake, and also decrease of torque means formation change, hole cleaning, decreasing the hole inclination, and decreasing the filter cake, etc. And bit balling also included. And also the pump pressure. So the pump pressure also measured in pounds per square inch psi. So the constant pump pressure should be norm once the recommended pressure is reached, and irregular pump pressure for the BH hanging up and increasing the pump pressure, which indicates the analyze is packing off and the bit is balling and inadequate hole cleaning, etc. Then the goes off to the also losing circulation, aerated drilling fluids, then pump strokes. That is your pump strokes. The following points should maintain. That is pump strokes included, washouts, lost circulation, etc. And decreased pump stroke means annular restriction, plugging, bit. And also the summary. So cost per foot analysis, what pulling the drill bit. So all the optimization will not make the bit lost for the entire oil well. Pulling the damaged bit is necessary to make the drilling operation more efficient. So the following 4 parameters keep in mind and determining when pull out the bits. That is cost per foot, break-even analysis, drilling rate, and drilling permanent change. So we can go through these 4 points. And the summary is that well site personnel will have all the responsibility in monitoring the efficiency of drilling operation and recommending to the waste to optimize the drill rate. And also monitoring the cost per foot curve and watching the surface drilling parameters, which will make you much more effective member in the drilling team. So this is the summary, and this is the bit number, etc. Then, so this is a self-check exercises, and you can see here the what are the types of bit maybe choose when the practices, etc. And the rig cost also is shown here. And here also determine the which series of bits are most economical for the operator. Then the graph break-even analysis, bit size, then which are bits to be compared, total trip time, rig cost per hour, total trip cost, and the total footage drilled, etc. So this is the analysis what you learned, and now from this we can do the better drilling. So we complete today the presentation on drilling cost analysis. So now, so we have now completed today's presentation, and in the next video, next presentation, we will see the more. So subscribe my channel. So we have completed today, and in the next class we'll see more, and today we'll learn more on the drilling cost analysis. So subscribe my channel. Thank you.